Okay, so we're now getting into orthographic projection for you. And what we do here is we draw, of course, 2D representation from 3D object. Yeah. So here you can see the whole body from top, front, and right sides. These are your projections. Yeah. We call this a 2D. Yeah, two-dimensional, and that's a three-dimensional. Your X, Y, and then your Z. Okay. So we can do our 2D drawings, yeah, and these are just the sides, yeah. You can see this object from 6 different sides because you have 1, 2, 3, 4, and then down 5, and then back 6, yeah. 6 sides for every object in 3-dimensional position, yeah. We can draw 2D drawings like this, okay, showing all features on the object by using different lines. Yeah, you can see here you have 2 different lines right there and all other solid line. Yeah, so we'll get to that later. So here are your 6 principal views. So you have your front, back, top, bottom, your left side, and then your right side. Yeah, we call them 6 views, yeah, in short, because you're looking at the object in these directions. Yeah. So let's take a look at how did we create the 6 principal views. So what we did, we placed the object in a glass box. Yeah, see that? So that's in the glass box. Let's kill this one so you can see. And then the image, yeah, of the object is projected, see, on the sides of the box. Yeah. And then we would take it apart. That means unfolding the box so you can see the sides of them. And these are all your 6 principal views. Yeah. So let's take a look at it. See, we unfold it. So going a little bit fast. Stop it here. Yeah. So 1, 2, 3, 4, 5, 6 views. From this side, from that side, from the front, top, bottom, and then the back. Yeah. So that's how we create the 6 principal views. Yeah. Okay, I'm just going to go ahead and play it again. All right. Now let's take a look at this. So here you have width, yeah, height, and then your depth, 3 quantities here. Yeah. These are your dimensions, and we keep the size and shape, okay, the same. Yeah. So your height doesn't change. See these relationship lines right there, connecting edge to edge. Your width doesn't change. See? So you can have these neat little projection drawings like that. Yeah. And the depth, because that's your top view, and this we call this the depth. Yeah. So you have width, depth, height. The same thing. When you look at it, that's your depth. Your height, you can't see it because you can see it only from your front view. Yeah. Your height, you can see it. So make sure you understand which one is your width, your height, and then your depth. Yeah. Practice. Okay, then we got to know how many views we need to draw for every object that we study. Yeah, you don't need to draw all 6 of them. So standard view, we usually do 3, front, top, and right. Sometimes you don't even need 3, depends on the shape of your object, okay? So we gotta find out the enough views. Yeah, here I highlighted to completely describe the shape. So what are the enough views? Your views got to contain, all right, the information of that object. So what are the information? Your depth, your width, your height. Okay, so that's what we need. So as long as you choose enough view to describe the object containing that information, you're good. Yeah, you don't even have to draw 3 of them. So let's take a look. Here you only need 2 views, because with 2 views, your front and then your top, you got all width, height, and depth. You don't need this because the C is repeated information, and we call that the duplicate information. Yeah, you need only 1 view here. Doesn't matter front or top or side. Yeah, regardless of the view, you can only get the circle out of a ball, yeah, because your diameter are the same. So the only information you need is the diameter of that circle, yeah, to draw it correctly. And one view is enough to describe this object, yeah. So we eliminate the other two and don't waste your time on it for the repeated information. This one you need two views, the same thing, yeah. We can eliminate either the top or the right side because you got it all, your width, your height, and then your depth. Yeah, your internal, which is this, yeah, this edge right there and that edge right there. We describe it with the hidden line, yeah, because we can't see it, of course, it's just covered with that side, the surface. So here, yeah, so you only need this and this, and you can get rid of either this or that. You can also get rid of this and show only this, yeah, because you got your height, width, and depth in it. We only need two views for this, yeah, so you can get rid of this. Your width, height, and the depth, and your internal features can be fully described by using only these two views, okay? Line type. So we have different types, yeah, of lines to describe the object of interest, because we want to know if the feature is visible or hidden. We want to know if the line is part of the object or part of the dimension. We want to know if the line is indicating symmetry. Okay, so now let's get into the four line types, right? So here are the names. We call it continuous, hidden, center, and phantom. So let's see what they are. So visible line looks like this, and it's just a straight, yeah, continuous line, and we use it to represent visible edges, boundaries, so meaning you can see them, yeah. The next one is the hidden lines. So they're dashed, okay, so look at this, a space in between them, yeah, little short dashes. The thickness in the visible line is about 0.5 to 0.6 millimeters. So your hidden lines, it's about half, yeah, so 0.35 to 0.45 millimeter. So hidden lines are thinner than your visible lines. So we use this line to describe the hidden edges, yeah, and the boundaries. So these are the edges and the boundaries behind a view that you can see directly. Okay, these are what you can see directly. Center lines looks like that, and center lines represent the axis of the symmetry. So you have your long dash, short dash, and then the long dash. So that's like about 0.3 millimeters, yeah. Your phantom line, we're gonna use this line, dash, long, short, and then long, yeah, to describe the ghost feature, so imaginary features, yeah. Phantom means a spirit or ghost, something that you imagine doesn't exist. To describe the alternate position of your moving parts of that object or adjacent positions, yeah, in the related parts. About 0.3 millimeters, yeah, thin line. Dimension and extension, we use it, yeah, to show the size of the object. So dimension lines is in between two extension lines, yeah. This is your extension line, that is your dimension line showing the value, the size of your object, yeah. And terminated by these two little arrows head, see? So that's just showing you the direction and extent, yeah, of your dimension, about 0.3 millimeters. Cutting plane lines, we use it, yeah, to show the imaginary cut through the object, yeah. So you can see the internal or interior features, okay, about 0.6 to 0.8 millimeter in thickness. And of course, you still have your arrowhead showing you the direction of your sight, okay? So direction of sight means like you can see the cutting plane, right, along that line. All right, the section line. So after you cut your object, yeah, you're gonna have two areas or surfaces, yeah, exposed to you, and we usually use a 45-degree angle to the horizontal line, right? So these lines are all 45-degree angle to the horizontal line, a group of lines, yeah, parallel to each other. We call them the section lines, yeah, about 0.3 millimeter. Of course, these are continuous, meaning there's no dash, yeah? Just a straight line parallel to each other, slanted 45 degree to the horizontal line, yeah? Break line looks like a little sine wave. So this is your first arc, second arc. Arc is just a part of your circle, right? Arc is a part of your circle, 0.5 to 0.6 millimeter, so thicker, yeah, double than 0.3 millimeter lines. Okay, so we usually use this line to show the imaginary breaks, yeah, in your objects. Okay, here let's take a look at this. So here you can see the hidden line, short dashes, cutting plane, yeah, line, showing you the line of sight, how we cut it right here at the center. This is your front view, but we're seeing where the cut is, yeah? So you can see the section lines showing you the cut surface. Here are all your internal features, something that you can see in between, yeah? And of course, here this is your right side view, looking at the object from this, yeah, line or direction. So you can see the internal feature, your hidden line, that's your center line, because you have a long dash and a short and a long, yeah? The same thing. You have a 1, 2, 3, three circles, yeah, going through the cylindrical circles. Just go straight in to this object, okay? You can see here, yeah, the depth of that. Your dimensions, yeah, from here to here, your width, your height, yeah. This is higher than that edge, yeah. And then of course your depth from your top view, which is this one, yeah, in your right view. Top view, front view, the right side view, yeah. Hidden line, okay. Visible line, center line, visible line, really thick. Make sure you know the thickness of it, see? Thinness here, 0.3. Okay, so let's get into your associated features. This is A, yeah? And what is that? It's right here, yeah? So your A is associated to this C feature from your front view. In the top view, you can see this very clearly. When you look at this feature on this object from the front, you can see it. So we use a hidden line, yeah? That's your A, and of course here too. Your B, visible line, we draw this guy, yeah? When you look at it, your A, from this side, you can see it, yeah? So therefore, we draw it, yeah? This way from the side, yeah? See this? So here going into there. So right side is you're seeing that. You see this circle right here, hidden. This surface is blocking that, yeah? So you can see them from this right side. So we draw the hidden line. And there's of course that, yeah? The lowest edge is right here, where the object is standing on that, this and that lake, two lakes, right there. The middle one, which we show it right here, yeah, kind of a little bit difficult for you to see from the front, but it's going inside, yeah, into it. And this one, yeah, your center of your circle right there, the center line is right in here. C, associated feature, yeah, it's right here. Okay, you can see this from this side because it's covered, yeah, right behind this edge. So behind this edge, yeah, from the top, it's right there, yeah. That's your associated feature C. Going straight in, yeah, you can see this edge from the top. So we draw hidden line. Okay, make sure you study this. Okay, let's see the rules. Line creation. So how are we going to use the hidden lines? So hidden lines, again, the same thing. Your edges and boundary that we cannot be able to see from our view. So rule 1. So these are the hidden lines. The dashes is going to vary, depends on the size of your object, yeah? Here is a bigger surface, and here, look at that. A smaller surface, yeah? Your view. And we can change the dash, according to the size of the view that we're drawing. Your rule 2, you have to begin with the dash and end with the dash. Okay, nothing is continuous here or dashed. But sometimes, see, if your hidden line begins or starts with a visible line, then you can't, draw the hidden line because it's behind this edge. The hidden line is behind that, so you don't have to draw, or even if you draw over it, you can see it. You can only see the partial hidden line. Of course, you still have another edge behind this edge. When you end the same thing, you can see it. So either this is this, look at this, ending in it. The same thing, you end at the visible line, right here. Rule number 3, dashes, they gotta join at corners, here, see that little corner right there, here, your angle right there, they join together. Okay, so we'll get into center line. The next line is a long dash, short dash, and then followed by a long dash. We're gonna, describe the axis of symmetry. So let's see. See, this side is exactly the same as that side in a circle because they have the same radius. This is your center. So that's what we call the axis of symmetry. Here, this is your axis. If you take this axis as a symmetry, then this side and that side is the same. Axis of symmetry, the same thing. That top side and the bottom side, they're the same. Meaning like from here to here, the distance is the same. From here to here, that distance is the same. So they're also used to indicate, right here, look at that, the center of circle of centers, many, 1, 2, 3, 4, circle. The next layer, another circle, and then another bigger circle, We can also see the path of your motion, so the motion going that way, So that's your center, 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 and center, and that's the same common center for 2, circles right in there. And here is your path of motion, describing this motion, look at that, and the path of motion right here. And we use a little, phantom line in there. Of course, here you can still see the circle, which is your center line, This is kind of fused because of the motion going around, but we'll come to the phantom line later. We're going to create the center line. You're going to start and end with long dash. Start with the long dash. Make sure this long dash pass the circle, You can't start from the circumference at all. You gotta start from the outside going into, the circle, cross the center with a dash, right? Short dash, and then the long dash. We do the same thing for the bigger, circle, long, short, and then long, Here, your intersection point of that 2, center line, is happening at that short dash. Here, your intersection point is happening at the long dash, okay? And that's okay, because that's our rule 2. It can cross long dash, it can cross short dash. So rule 3, center lines. You gotta extend a short distance beyond the object, beyond the object or feature. This is your object, that is your feature. This is your center line. That gotta go beyond, meaning like you can't stop the center line right here on the edge. You gotta go out, go out, out, and out of the object and the feature. This is incorrect, because we're stopping. See, look at that, at the boundary, okay? You don't stop like that. So make sure you understand that. Rule number 4, center lines may be connected. You can connect within a single view. This is your let's say front view, we can't say front or top, but or right, whatever. We can assume this is one of the view to show that 2 or more features, okay? So you can connect within a single view to show two or more features, first feature, second features. Yeah. Of course, that two features, they lie in the same plane. This is your plane. Yeah. Okay. So even if our rule, right, the previous rule told you to extend your center line past the feature, yeah, past the object, it doesn't say to extend, yeah, your center line past the view. It's got to stay within the view. Yeah, so that's what rule number 4 is saying. Caution. So make sure your center line, right, won't extend through the space between the views. So now I have a boundary. This is not object, that's the view. Yeah, so you can't draw your center line out of your view. It's got to stay within the view, but out of your feature and out of your object. Yeah, but stay within the view. See, out of the object, but in the view. So this rectangular box is your view boundary. This is your object boundary. Past the object boundary, the circle is your feature in the object. Past the feature boundary, but never ever pass. Yeah, the view boundary, and that's what it's saying. Okay, so make sure you be careful with that. Okay, so come back to the other previous problem to show the phantom line. So your phantom line is 2 dashes. Yeah, so long dash followed by 2 dashes and then followed by a long dash is your phantom line, and it's going to show your ghost features. Yeah, we can see. So this is a ghost feature for the motion. Yeah, so here we move along that. So showing all the positions, yeah, on your moving parts. This is just a center, yeah. Adjacent position of your related parts. So here is your first part, and that is a related part, which is under, yeah, under the object of interest, which is this is our 3D object. But then there's a related part made it to the 3D object that we're studying, yeah. So when we are putting this part, yeah, into the glass box, since they're mated, you still have to account for the part that is related to the part of interest. Yeah, so this we call a related part, and when we draw it, we gotta ghost it out by using the phantom line. Yeah, of course the internal features we still show. Yeah, this one is there's a diameter like straight down. Your cylinder, yeah, your circle cylinder is still going the first object and then going into the related part. Of course, we still have to use the hidden lines to show that, but the boundary of the related part, which is not included in our object of interest, we show with the ghost line, yeah, which is your phantom line. Okay, repeated details. So here you have a repeated details. Look at that. Look at this. Yeah, it's the same thing, and we also use, yeah, to show the this part and that part repeated details with the phantom lines. Yeah, we also use a phantom line to show a change in your, again, surface, yeah, direction produced by your fillets and then your rounds. See, look at that. So this is your first fillet, second, third, yeah, changes. So we show all of that with the phantom line because we can't really, yeah, show it any other line. So here, yeah, going with the phantom line, we show the change in the surface direction because of these fillets, because of these round right there. Yeah, so surface directions. It's kind of like a movement, but it's a kind of still, yeah, just a change in the features and the directions that we're showing with the phantom line. Okay, the last rule, how are we going to create it? So, sorry, the first rule, how are we going to create the phantom line? You're going to start, yeah, with a long dash, and then followed by 2 short dashes, and then end by a long dash. Break lines. So let's take a look at how to use the break lines. So break lines we use to show the imaginary breaks in our object. Yeah, so look at that. This is a break. Yeah, and here look at this little, yeah, series of arc. We have only, for this example, we have only 2. Yeah, one here and one there, one here and then one there. Yeah. So we used to show the imaginary breaks in our object. So how we're going to create it. So there are two types of break lines that we draw. If the distance to travel is short, like a little short break, yeah, we're going to use this kind of like a sine wave kind of, connecting arcs, yeah. If the distance is long, right, we're going to use a straight line, yeah, with a jog, and this is a jog right there, in it. So we have a short distances thick, and then we have long distances thin, yeah. All right, so line precedents. So the line precedents are different. Okay, so the line precedence. So line precedence is nothing but we give the importance, yeah, which line to use first. So in order of your importance, first is your cutting plane line, yeah, then followed by visible line, hidden line, and then your center line. So why do we need the line precedence is if you have like two lines, right, in the same place, you're going to get rid of the one that is not important. So if you compare cutting plane line and hidden line happen to be at the same place, you can get rid of your hidden line. If you have like a visible line and center line, you can get rid of the center line, yeah? So that's what it's saying. So make sure you get this order: cutting, visible, hidden, and center. Okay, let's get into our view. So the very first one is your top view. So this is your top view, and you can see, yeah, this is your line of sight, that's your eye looking down, yeah, and you can see, look at the surface we see, yeah, and also there's another surface here behind this, yeah. I painted yellow right here for you, yeah, and we draw it, see, visible line. Your feature is a circle. There's another one down there, yeah, but we can't see it. So there's a hidden circle right underneath of that, but we don't have to draw it because of the precedence, yeah. So visible line, and then go down to the hidden line. So if you don't remember the precedence, you can see, yeah, visible line is have more importance than the hidden line. So you can omit the hidden line right underneath of that. Yeah, of course you still draw. See, this is covered by that, yeah. So that's what you're seeing. And then of course this, see this line, and that's the line inside of it, okay, going straight down. You can see it from the surface. Pay attention to all of that very carefully. Okay, front view, looking at the object from this line of sight, and here is your eye. So you've got your blue surface and then green surface that we can see. Yeah, your green, your blue. See, your hidden line, a little bit fused right there. That's just a short dashes. And the axis of your circle right there. Yeah, center. The center of your circle with the diameter, yeah, cross. So two radius on each side right there. So that's your front view. Alright, then get into the side view. Looking at from here, we can see the red. See, yeah, red. Of course, the edges of the surface, but we don't see the surface because it's slanted, inclined surface right there. We draw this surface, we draw that surface, see? In our circle, two features, center of the circle, see, straight down hidden lines in there. And here, there's another edge right there that we see, see that? Which is behind the surface. So therefore, we draw the dashed line. There's another edge right here, yeah? So this edge, yeah, is that. Your depth is there, yeah? Your height is right here. And this little line, yeah, is that. Yes, the lower boundary of your top, this part. And then that one is this. Okay, be careful when you draw. Okay, so let's create the orthographic projection. We're gonna choose a front view. Yeah, that's one of your standard view. Usually we start with the front view or top. So this is a view that shows the most about the object. So when you look at it from this direction, that you can see. Yeah. Number 2. Step 2, we're going to design how many views that we need to describe that object. Yeah. So thinking about width and the height and the depth, and that information you need to contain in your, of course, your feature on it. If you cannot be able to do that, just make sure that you draw all three views. Yeah, never go wrong. And then eliminate the repeated features. Yeah, somebody doing something in the back. So yeah, so sorry, some noise in the back. Okay, front view. Looking at it, then we will start drawing the visible. Yeah, what you can see directly with a visible line. See, pretty straightforward. Okay, then we're going to attempt to draw the top view and the right side. So in order for us to do that, we're going to start with our projector. The projector is going to keep the shape, the size of this, yeah? Not the shape, I'm saying like, okay, size of it. So it's going to go straight up, meaning like it won't go beyond this line. We won't go beyond that line. Your object, yeah, the projection got to stay in between. Yeah, so you have a vertical project, front view, horizontal project, and the right side view going in there. Then we're going to draw the top view. Yeah, we're going to keep the exact same dimension, which is the width, the same as that. Yeah, and we're going to use the vertical projectors to fill in the visible. Yeah, and then the hidden features. So you have a hidden features right there. Yeah, so we draw bang, which is this guy down there, and that guy down there, and then your circle we can see it from the top. Yeah, very clearly. Then we're going to project from the top view back to the front view because we want to draw this hidden feature, which is your circle. Going back down, because we need that dimension, yeah, the diameter of the circle. We can see that circle from the top view very clearly, but you can't from the front view, yeah. So you can estimate. So therefore, we've got to draw what we can see with the visible line first, and then go down and do the same thing, yeah. Okay, now we get the hidden features for the front view, which is this little cylinder, yeah, which is your hole in, yeah, your object by this feature circle, yeah. We're gonna draw, yeah, 45-degree miter line. So anyway, so go draw 45-degree, project it off upper right corner of your box from your front view, yeah. So go straight, measure from the horizontal line right here, cut it out. Your angle got to be 45-degree. Then draw a straight line, bang, yeah, because we want to attempt to draw the right side. Okay, from the top view, we're going to draw our projectors again. Yeah, go all the way, cross this line, and straight down. Go all the way from here, cross this line, straight down. Go all the way from there, cross this line, straight down. And this is your object boundary, yeah. So object leg is right there. So go down. And we're going to draw the right side view. Completed it. Yes. You have your hidden features. You've got your circle, your internal feature of that circle is your little cylinder right there. Hidden because you can see it from the right side, inside, yeah. Covered by this surface. So we do hidden lines. And you still have another edge, see? So where this corner is, that go all the way to the end of the corner on the back side, yeah? So that's what you're seeing right here. Okay, then we're going to project back to the top and the front view from the right side view if you need it, okay? So going backwards. And right now you don't need it because it's all correct information, yeah? Completed information anyway. And then we're going to draw the center line, so where it is necessary. So here, circle, center line, so long dash, short and long, long, short and long. Draw it, yeah, past the object boundary, but never pass, yeah, the view boundary. So we don't have a view boundary right here, yeah. So here, object boundary and the feature boundary. So here is your feature boundary. By looking at from the top view, yeah, you gotta cross this circle circumference. So here is your object boundary, this, yeah, 3D, this edge, yeah. So therefore you can be able to see the center line and make sure you represent, oh, that is the center of this circle, yeah. And from the front view, you can see into it because this surface is totally blocking, yeah, everything that is behind this surface. So we draw it down, yeah, and of course it pass your object under it. So see a little line hanging out right there. And if I don't see this line protruding out of the object, yeah, that's a -1, yeah, for your points. Okay, adjacent or related view. So this view and that view adjacent to each other. This view and that view, so front and right adjacent to each other. Your front and top adjacent to each other. Okay, top and right side related to each other. Yeah, and here is your depth that is equal to each other. Yeah, this is your width equal to each other. Your height equal to each other. Yeah, so we call this the horizontal projectors. Everything that is connecting lines from point to point, yeah, or the edge boundaries to edge boundaries, we call them, or features boundaries, we call them the projectors, horizontal projectors. So these are your vertical projectors, right? And this is your 45-degree meter line, yeah, and they equal to each other, depth and the height, and then the width. Okay, relationship. Okay. Then here is a completed drawing, yeah, other drawing. We have our neat little, yeah, the front view, our neat little top, and then a very clearly drawn, yeah, right side view. Okay, all the features are there, nothing is missed, and then the lines are appropriately and correctly, yeah, representing every features in this object, yeah. Okay, so make sure you practice the orthographic projection drawing, please. Yeah, that's it for today.